The intricate ballet of space operations continues to unfold, with recent developments highlighting both the meticulous caution required for human spaceflight and the enduring mysteries of the cosmos. As NASA adjusts launch schedules and astronomers ponder unexpected signals, the public's fascination with space is simultaneously fueled by new tangible connections to its rich history. The highly anticipated Axiom Mission 4 Ax-4 to the International Space Station ISS has experienced a delay, with NASA announcing a stand-down from the previously targeted June 22 launch. The decision, made in conjunction with Axiom Space and SpaceX, stems from the need for additional time to thoroughly evaluate ISS operations. Specifically, the space agency is reviewing data following recent repair work in the aftmost segment of the orbital laboratory's Zvezda service module. Given the station's interconnected and interdependent systems, NASA emphasizes the importance of ensuring the ISS is fully prepared to receive additional crew members, prioritizing safety above all else. The Ax-4 crew, comprising former NASA astronaut Peggy Whitson, Commander ISRO Indian Space Research Organization astronaut Shubhanshu Shukla, pilot ESA European Space Agency project astronauts Laszlo Uznansky of Poland and Tibor Kapu of Hungary, remains in quarantine in Florida, ready to launch once the station is deemed ready. This mission holds significant historic weight for India, Poland, and Hungary, underscoring the growing international collaboration in commercial space endeavors. Despite the delay, SpaceX's Falcon 9 rocket and Dragon spacecraft remain in healthy condition at Launch Complex 39A at NASA's Kennedy Space Center. Meanwhile, the vastness of space continues to present perplexing phenomena. Astronomers are currently puzzled by a powerful burst of radio waves traced back to a NASA satellite, Relay 2, which had been inactive since the 1960s. Launched in 1964 as an experimental communications device, Relay 2 ceased active use by NASA the following year, with its onboard electronics failing completely by 1967. This dead metal hull, orbiting Earth for decades, unexpectedly emitted a pulse strong enough to briefly outshine every other object in the sky. Scientists are theorizing that the sudden emission could be the result of a freak micrometeorite impact or a random spark within the satellite's dormant systems. This incident serves as a stark reminder of the unpredictable nature of objects in orbit and the enduring mysteries that even human-made space debris can hold. In other celestial news, NASA has also reportedly raised the chance for an asteroid to potentially impact the Moon, an ongoing area of observation and analysis for planetary defense. Beyond the immediate challenges of orbital mechanics and the enigmas of deep space, NASA's legacy continues to resonate, even inspiring creative endeavors closer to home. LEGO recently unveiled a new NASA-themed set, a rendition of the U.S. Space Agency's Boeing 747-based shuttle carrier aircraft with a space shuttle perched atop. Priced at around £200, $229.99, the set is effectively two models in one, featuring LEGO's take on a Boeing 747 and a scale model of the test Space Shuttle Enterprise. While praised for its engaging 8-hour build and impressive internal mechanisms such as the deployable landing gear on the 747, the set has drawn criticism for its scale compromises and reliance on numerous stickers rather than pre-printed parts. Reviewers note that while the shuttle is recognizable, it contains plenty of inaccuracies and visible studs, suffering in comparison to LEGO's more detailed Space Shuttle Discovery set. Similarly, the iconic front of the Boeing 747 appears blocky and misshapen due to component limitations at the chosen scale. Nevertheless, the set serves as a fun set to build and a good springboard for discussing how NASA tested the space shuttle, highlighting the agency's enduring cultural impact and its ability to inspire new generations through play and historical reflection. As NASA navigates the complexities of current missions, grapples with cosmic anomalies, and continues to inspire through its storied past, these diverse developments collectively paint a vivid picture of humanity's ongoing multifaceted engagement with space. From ensuring the safety of astronauts on the ISS to unraveling the secrets of long-lost satellites and commemorating historical milestones, the journey of space exploration remains as dynamic and captivating as ever. promising further insights and adventures in the years to come. The eagerly anticipated Axiom Mission 4 Ax-4 to the International Space Station ISS has encountered further delays, with NASA, Axiom Space and SpaceX announcing a stand-down from the previously targeted June 22 launch. This latest postponement stems primarily from ongoing evaluations of the orbital laboratory systems following recent repair work, underscoring the meticulous safety protocols governing human spaceflight. Originally eyeing a launch as early as June 10, the Ax-4 mission has faced a series of rescheduling. An earlier delay was attributed to the need for SpaceX teams to address a liquid oxygen LOX leak identified during post-static fire booster inspections on the Falcon 9 rocket. While that technical issue on the launch vehicle at Kennedy Space Center's Launch Complex 39A has since been resolved, clearing the way for liftoff from a hardware perspective, the focus has now shifted to the readiness of the ISS itself. NASA has indicated that additional time is required to thoroughly assess International Space Station operations, specifically in the wake of repair work conducted on the aft segment of the orbital laboratory's Zvezda service module. Roscosmos cosmonauts recently completed efforts to halt a long-monitored leak in this area. Following these repairs, a new pressure signature was observed, prompting NASA to exercise caution. Because of the space station's interconnected and interdependent systems, NASA wants to ensure the station is ready for additional crew members, and the agency is taking the time necessary to review data, the agency stated, highlighting the critical importance of ensuring the station's stability and safety before welcoming new occupants. This diligent approach reflects the inherent complexities of managing a multi-decade-old orbital outpost and its intricate, interdependent life support and operational systems. The Ax-4 mission is set to be a landmark private astronaut mission commanded by former NASA astronaut Peggy Whitson, who also serves as Axiom Space's Director of Human Spaceflight and holds the record for most days in space by any American astronaut. She will be joined by a diverse international crew, ISRO Indian Space Research Organization astronaut Shubhanshu Shukla serving as pilot, ESA European Space Agency project astronaut Sław Uznański-Wisniewski of Poland, and Tibor Kapu of Hungary, both mission specialists. This mission carries significant historical weight, marking the first government-sponsored human spaceflight in over 40 years for India, Poland and Hungary, and the first time all three nations will execute a mission on board the ISS. NASA, Axiom Space and SpaceX have collectively acknowledged the historic nature of this mission for the nations of India, Poland and Hungary, as well as the world. The crew remains in quarantine in Florida, prepared for launch once the station is deemed ready. Once launched aboard a SpaceX Dragon spacecraft, which will be making its first flight, the Ax-4 crew is slated for a 14-day stay on the orbiting laboratory. During their time, they are scheduled to conduct more than 60 scientific experiments and demonstrations. These research endeavors will span critical areas including human research, Earth observation, and various life biological and material sciences, contributing to the growing body of knowledge derived from microgravity environments. The Falcon 9 first stage booster supporting this mission, which previously launched a Starlink mission, is planned for a second flight and will land on Landing Zone 1LZ1 at Cape Canaveral Space Force Station. The ongoing delays, while frustrating for those eagerly awaiting the launch, underscore the paramount importance of safety in space exploration. They serve as a stark reminder of the intricate dance between cutting-edge technology, human ambition, and the unforgiving realities of orbital mechanics and complex space infrastructure. As NASA, Axiom Space and SpaceX continue their assessments, the global space community remains hopeful for a swift resolution and a new launch date, allowing this historic international mission to finally take flight and further expand humanity's presence and scientific endeavors in low Earth orbit. The collaborative spirit demonstrated by these partners in navigating technical challenges will undoubtedly pave the way for future commercial and international space ventures, solidifying the ISS's role as a vital hub for global scientific discovery. The ambitious Axiom Mission 4, poised to transport a groundbreaking international crew to the International Space Station ISS, finds its launch timeline in flux, underscoring the intricate dance between cutting-edge technology and the meticulous demands of orbital safety. What was initially eyed for a launch on Sunday, June 22, has been indefinitely postponed, a decision stemming primarily from ongoing assessments of the International Space Station's operational health following recent repair work. This commercial mission, spearheaded by Axiom Space in partnership with NASA and SpaceX, is set to be a landmark endeavor featuring a diverse quartet: former NASA astronaut Peggy Whitson, who will command the mission for Axiom Space, Indian Space Research Organization ISRO astronaut Shubhanshu Shukla as pilot, and European Space Agency ESA project astronaut Sława Uznański-Wisniewski of Poland alongside Tibor Kapu of Hungary as mission specialists. This crew represents a significant step in global space collaboration, highlighting the growing accessibility of human spaceflight to nations beyond the traditional space powers. The current delay is rooted in critical maintenance performed on the ISS. NASA has confirmed the need for additional time to thoroughly evaluate the orbital laboratory systems, specifically after repair work was completed in the aft segment of the Zvezda service module. This module has been the site of a persistent leak monitored by flight controllers for several years, which Roscosmos cosmonauts recently addressed. While initial reports indicate the repairs stabilized pressure in the transfer tunnel and hatch seal between the ISS and Zvezda, NASA is exercising extreme caution. The agency cited the space station's interconnected and interdependent systems as the reason for requiring more time to review data and ensure the station is unequivocally ready to accommodate additional crew members. This meticulous approach is paramount, given the unforgiving environment of space and the inherent risks involved in human missions. Earlier in the mission's preparation, the SpaceX Falcon 9 rocket, which will carry the Dragon spacecraft, also experienced a liquid oxygen leak. However, SpaceX teams have since reportedly repaired this issue and completed a wet dress rehearsal, confirming the rocket's readiness for liftoff once the ISS is cleared. This two-pronged challenge, addressing both ground-based launch vehicle issues and in-orbit station integrity, highlights the multifaceted complexities of modern space operations. The repeated shifts in the launch date, moving past previous opportunities, reflect NASA's unwavering commitment to safety as the paramount concern. For the Axiom Mission 4 crew who remain in quarantine in Florida, the waiting game continues, a testament to the patience and professionalism required of astronauts. Despite the delays, the historic nature of this mission for the nations of India, Poland, and Hungary, as well as the world, remains a central theme as articulated by NASA, Axiom Space and SpaceX. Once launched, the 14-day mission is slated to conduct dozens of experiments and scientific research, contributing valuable data to various fields. As the agencies continue their rigorous data review, the situation underscores the delicate balance of maintaining an aging yet vital orbital outpost while simultaneously expanding commercial human spaceflight opportunities. The ongoing collaboration between NASA, Roscosmos, Axiom Space, and SpaceX navigating these technical challenges serves as a reminder of the global effort required to sustain humanity's presence in low Earth orbit. The world watches, eagerly anticipating the day when the Ax-4 crew can finally embark on their journey, pushing the boundaries of scientific discovery and international cooperation in space. In a week marked by both ambitious spaceflight aspirations and profound scientific discoveries about our planet's ancient past, the spotlight has fallen on the intricate dance of orbital operations and the enduring resilience of life. The highly anticipated Axiom Mission 4 Ax-4 to the International Space Station ISS has faced another postponement as NASA, Axiom Space, and SpaceX continue to meticulously evaluate the orbital laboratory's readiness following critical repair work. Originally targeting a June 10 launch, then June 11, and most recently June 22, the Ax-4 mission has been paused to allow NASA additional time to continue evaluating International Space Station operations after recent repair work in the aft backmost segment of the orbital laboratory's Zvezda service module. This cautious approach underscores the inherent complexities of maintaining a habitable environment in orbit, with NASA emphasizing that because of the space station's interconnected and interdependent systems, NASA wants to ensure the station is ready for additional crew members, and the agency is taking the time necessary to review data. This latest delay follows an earlier standing down from a June 11 launch target due to a liquid oxygen LOX leak identified during post-static fire booster inspections, a testament to the rigorous pre-flight checks essential for crewed missions. Despite the delays, the four-person Ax-4 crew remains in quarantine in Florida, poised for their historic journey. The mission will be commanded by former NASA astronaut and Axiom Space's Director of Human Spaceflight Peggy Whitson, America's most experienced astronaut with a record 665 days in space prior to her last mission. She will be joined by ISRO Indian Space Research Organization astronaut Shubhanshu Shukla serving as pilot and two mission specialists, ESA European Space Agency project astronauts Laszlo Uznansky of Poland and Tibor Kapu of Hungary. This mission carries significant international weight, marking the first time India, Poland, and Hungary will each have a government-sponsored astronaut on board the International Space Station, a historic mission that underscores how Axiom Space is redefining the pathway to low Earth orbit and elevating national space programs globally. The crew is slated to conduct over 60 scientific experiments and demonstrations during their time on the orbiting laboratory, focusing on critical areas such as human research, Earth observation, and life, biological and material sciences. Meanwhile, SpaceX's Falcon 9 rocket and Dragon spacecraft, with the booster on its second flight after a previous Starlink mission and the Dragon on its first, remain healthy at Launch Complex 39A at NASA's Kennedy Space Center. While humanity continues to push the boundaries of space exploration, scientists are simultaneously peering back into Earth's deep past, uncovering remarkable insights into the resilience of life itself. New research from MIT published in Nature Communications suggests that early complex life forms, or eukaryotes, may have survived the planet's extreme snowball Earth periods between 720 and 635 million years ago by sheltering in meltwater ponds. During these cryogenian glaciations, the planet was largely plunged into a deep freeze, with average global temperatures plummeting to -50 degrees Celsius. The enduring mystery has been how and where life, particularly complex cellular life that predated the explosion of diverse multicellular forms, managed to persist. We're interested in understanding the foundations of complex life on Earth, explained Fatima Hussein, a graduate student at MIT and lead author of the study. We see evidence for eukaryotes before and after the cryogenian in the fossil record, but we largely lack direct evidence of where they may have lived during. To address this, Hussein and her colleagues explored the hypothesis that meltwater ponds akin to those found on modern-day Antarctica could have served as crucial refugia. By analyzing samples from meltwater ponds on the McMurdo Ice Shelf in East Antarctica, where microbial mats thrive, the researchers sought to understand if these harsh yet surprisingly diverse environments could support eukaryotes. Using advanced techniques to identify specific lipid sterols and genetic components, ribosomal RNA, they found a surprising diversity of eukaryotic life within these ponds, including various types of algae, protists, and microscopic animals. No two ponds were alike. There are repeating casts of characters, but they're present in different abundances, Hussein noted, adding, and we found diverse assemblages of eukaryotes from all the major groups in all the ponds studied. The profound implication, she concludes, is that these eukaryotes are the descendants of the eukaryotes that survived the snowball Earth, suggesting that these above ice oases were instrumental in nurturing the eukaryotic life that ultimately led to the diversification and proliferation of complex life on Earth, including our own. From the meticulous preparations for launching humans into orbit and ensuring the safety of the ISS to uncovering the ancient secrets of life's survival on a frozen planet, these concurrent narratives underscore the breadth of scientific and technological endeavor. The Ax-4 mission's delays serve as a reminder of the inherent challenges and critical safety protocols governing human spaceflight, while the snowball Earth research highlights the incredible adaptability of life and the Earth's dynamic history. Both endeavors in their unique ways continue to push the boundaries of our understanding, promising further revelations as we navigate the complexities of both the cosmos and our own planetary past. The allure of Mars continues to captivate humanity, with recent robotic missions consistently unveiling the red planet's ancient secrets, even as the ambitious endeavor of human and sample returns faces formidable Earthbound challenges. From perplexing geological finds to the persistent hunt for signs of past life, Mars remains a dynamic frontier, its mysteries deepened by every new observation. One of the latest intriguing discoveries comes from NASA's Perseverance rover, which after 4 years traversing the dust and bedrock of Jezero crater encountered a charcoal-colored boulder dubbed Skull Hill, on which Hazel Hill. This roughly foot-tall 1.6-foot-wide rock stands out starkly against the surrounding tan sandstone, its basalt-black skin immediately signaling its foreign origin. As Katie Morgan of NASA's Jet Propulsion Laboratory JPL aptly put it, every fresh turn in the RIM campaign has produced surprises. And Skull Hill is all we had hoped for and more. Scientists refer to such isolated transported rocks as floats because they lie loose on the surface, carried far from their original location by powerful forces. The Jezero Rim is a geological treasure trove preserving a cross-section of Mars's crust, and each float offers invaluable clues to terrains now eroded or buried elsewhere on the planet. Indeed, the mission blog notes, we found a few of these dark-toned floats in the Port Anson region. The mechanisms behind Skull Hill's journey are varied, painting a vivid picture of Mars's tumultuous past. 3 billion years ago, Jezero hosted a vast lake fed by rivers that likely transported cobbles from southern highlands into the basin before the water vanished. Later massive impacts would have churned up deeper layers, hurling projectiles across the landscape. Models suggest a 0.6-mile-wide crater could scatter ejecta more than 12 miles downrange, easily reaching which Hazel Hill. After the water receded, aeolian abrasion took over, with relentless sand-laden winds sculpting rock faces, creating facets and shallow pits like those observed on Skull Hill. Initial analysis of Skull Hill aimed to determine if it was a meteorite similar to egg rock found by the Curiosity rover in 2016. However, Perseverance's supercam laser, which fires a 5-nanosecond pulse to heat surface grains to plasma for elemental analysis, quickly revealed scant nickel, pushing investigators towards an igneous origin. Dark-toned units elsewhere in Jezero, such as the Moz Formation, are rich in olivine and pyroxene minerals that crystallize from cooling magma. If Skull Hill is a piece of this volcanic crust, it could have been excavated by impacts or fractured during ancient quakes. Still, a stony meteorite composed of chondritic material which contains far less nickel has not been entirely ruled out, with ongoing LIBS measurements promising to refine elemental ratios to better than 5% precision. The rover's sophisticated suite of instruments, including Mastcam-Z stereo imaging and microscopic color close-ups, allows geologists to marry chemistry with context, matching mineralogy to grain size and erosional features. Perseverance has been working at a record pace, probing 83 targets with its laser, on which Hazel Hill alone. The significance of floats like Skull Hill extends far beyond their immediate geological curiosity. A single exotic sample can point to rock layers tens of miles away, serving as a geologic telegram from terrains the rover may never visit. If volcanic, it could anchor the age of eruptions suggested by orbital mapping, potentially calibrating crater count chronologies used across the red planet. If identified as a meteorite, its weathered fusion crust and corrosion rines would offer crucial insights into how metals rust under Martian climate cycles, information vital for designing future human hardware. Even the pits on the rock chronicle present-day wind power, aligning with models that predict gusts exceeding 40 miles per hour at midday, strong enough to abrade exposed rocks. While the scientific bounty from Mars continues to grow, the ambitious Mars Sample Return program faces significant headwinds. Skull Hill lies only yards from a planned cache site where the rover could seal core samples in titanium tubes for a future pickup. Yet the program is grappling with a shrinking budget and an $11 billion cost cap that NASA Administrator Bill Nelson called too expensive in 2023. NASA has since tasked industry teams with redesigning the mission to trim billions from the price tag and launch later this decade, with samples potentially reaching Earth in the mid-2030s. The broader landscape of Mars exploration is also influenced by the private sector, notably Elon Musk's SpaceX. However, a recent massive rocket explosion has stirred renewed discussion about setbacks and whether Musk's ambitious Mars timeline might be more distant than initially perceived. Such incidents highlight the inherent risks and complexities of developing the next generation of space launch systems crucial for deep space endeavors. Adding another layer of celestial concern, NASA has also raised the probability of an asteroid 2024 YR4 impacting the Moon. New data collected by the James Webb Space Telescope refined the asteroid's course, increasing the likelihood of a lunar strike on December 22, 2032 from 3.8% to 4.3%. The 200-foot diameter space rock, if it were to hit, could create a crater approximately 3,200 feet wide, releasing 6.5 megatons of energy and ejecting as much as 220 million pounds of lunar material. A research paper notes that up to 10% of this ejecta could fall to Earth days later, potentially creating an eye-catching meteor shower, though meteorites are unlikely. Furthermore, any moon bits heading towards Earth could increase the meteorite impact exposure for satellites in near-Earth orbit for up to a decade. The ongoing discoveries on Mars, from enigmatic rocks to mysterious formations like the mushroom recently spotted by the Curiosity rover, underscore the red planet's enduring capacity to surprise and challenge our understanding. Yet these scientific triumphs are inextricably linked to the engineering prowess and financial commitments required to sustain such endeavors. As Perseverance continues its diligent work along the Jezero crater rim, zapping floats and drilling cores, the future of Martian exploration hinges on overcoming both the technical hurdles of space travel and the budgetary constraints here on Earth, ensuring that the next generation can truly unlock the secrets held within Martian soil and beyond. In a celestial dance that constantly reminds us of the dynamic nature of our solar system, recent reports have spotlighted both the predictable beauty and the potential perils orbiting our planet. On Friday, June 20, 2025, while stargazers observed a familiar waning crescent moon, a more urgent narrative unfolded as NASA significantly raised the probability of a city-killer asteroid striking Earth's natural satellite, a development driven by fresh observations from the James Webb Space Telescope. This heightened alert from NASA, reported by AccuWeather, MSN, and NDTV, underscores the critical work being done in planetary defense. The asteroid, characterized as a city killer due to its estimated size, poses a risk not to Earth directly but to the Moon. However, the potential impact carries a chilling secondary threat: the possibility of hurling deadly debris toward our home planet. Scientists are meticulously analyzing new data from the James Webb Telescope, which offers unprecedented clarity and precision in tracking celestial objects, allowing for more refined orbital calculations and consequently updated impact probabilities. This ongoing vigilance highlights the importance of advanced astronomical instruments in safeguarding Earth from cosmic threats, even indirect ones. Meanwhile, for those looking skyward on this same day, the Moon presented itself in its waning crescent phase, a familiar part of its 29.5-day lunar cycle. According to NASA, as detailed by Mashable, only 31% of the Moon's surface was visible from Earth, marking the 24th day of its current cycle. Despite its diminished illumination, keen observers, especially from the northern hemisphere, could still discern prominent features like the vast Oceanus Procellarum, often dubbed the Ocean of Storms, which spans over 1,600 miles and covers more than 10% of the lunar surface. Also visible was the Kepler crater, whose impact material spreads an impressive 185 miles, 10 times the crater's diameter, a testament to the powerful celestial collisions that have shaped our Moon over billions of years. These features, visible for several days around the third quarter phase, serve as silent witnesses to the very type of event NASA is now monitoring. The Moon's phases from the invisible new moon to the fully illuminated full moon, which occurred on June 11 with the next expected on July 10, are a predictable consequence of the changing angles between the Sun, Earth, and Moon as our satellite orbits us. We consistently see the same side of the Moon, but the amount of sunlight reflecting off it varies, creating the 8 distinct phases. This cyclical predictability, however, stands in stark contrast to the unpredictable nature of stray asteroids. The current asteroid alert serves as a potent reminder that while the Moon faithfully completes its orbital dance and exhibits its regular phases, it also acts as a celestial shield, absorbing impacts that might otherwise threaten Earth. The dual focus on the Moon's serene predictable cycle and the sudden alarming prospect of an asteroid collision encapsulates the ongoing narrative of space exploration and defense. As humanity continues to push the boundaries of astronomical observation, our understanding of the cosmic neighborhood deepens, revealing both its inherent beauty and its occasional dangers. The refined predictions made possible by instruments like the James Webb Telescope are crucial for planetary defense, ensuring that even as we marvel at the Moon's familiar visage, we remain ever vigilant against the less welcome visitors from the depths of space. This ongoing interplay between discovery and defense will undoubtedly continue to shape our relationship with the cosmos for years to come.